Okay, hello. This is Andrew Rink from NVIDIA, broadcasting from the NXTBLD 2020 virtual conference. Thanks for taking a moment to join this presentation on overcoming collaboration challenges in architectural design. I wanted to kick things off with a look at a few significant trends that the AEC industry is seeing when it comes to building and infrastructure design. Of course, as we all know, there are a lot of moving parts with AEC projects where typically a wide variety of team members and their clients work together, grappling with numerous processes. Geographic dispersion of contributors from a broad range of disciplines is commonplace for global AEC firms while collaborating on designing buildings. That expertise is often located remotely. For example, a lighting expert in New York City, an acoustics consultant in London, with perhaps the owner-developer residing in Shanghai. So companies are finding talent all over the world, and they have to deal with the complexity of managing these widely distributed project teams, all working together under tight deadlines. And not only are milestones, deadlines, and margins getting tighter, but building projects are becoming more complex, and the requirement to deliver those projects more quickly and more cost effectively keeps growing. Another trend that has gathered pace in the past couple of years is companies adopting leading edge technologies that help them optimize building designs and lower construction costs by reducing rework. This trend is being partly propelled by a need for better design visualization of building interiors and exteriors, which drives faster, more confident decision making. So more firms have embraced virtual reality and photoreal rendering and using those technologies early in the design process. In addition, we're increasingly seeing a desire by architecture firms to simulate their designs before construction begins. By accurately simulating how the building will appear and function in real life, for example, how airflows behave inside and around structures, or how sunlight reflects off glass surfaces at various times of the year, that level of accurate simulation is proving to be extremely helpful to teams for identifying flaws and optimizing designs. As a result of these industry trends, the obstacles faced by AEC firms become a bit more challenging. Efficient collaboration has typically been problematic, but it's getting even more so these days. Those geographically dispersed teams can have difficulty exchanging ideas and information, and that can result in duplication of work or delays with agreeing on decisions. It's also difficult to effectively communicate design intent when a project team is made up of so many different contributors with varied areas of expertise. And of course, you throw in the client into that mix, which naturally is a necessary complication. Often clients and even project members have trouble visualizing how building interiors and exteriors will appear in real life, and many software tools lack high quality visual outputs. So extensive discussions are needed before making decisions with confidence. The result is lengthy design review cycles, which ultimately leads to delays, and many of us have had to work through those. A third area of challenge is optimizing IT infrastructure. Companies need to maintain high productivity with a flexible global workforce. That means onboarding and offboarding project team members quickly and cost effectively. Those employees require quick access to secure datasets from anywhere at any time on any device. Then there's the lack of interoperability between design and visualization software tools, which is a pretty significant cause of wasted time with data translation, not to mention errors, but also often requires time-consuming decimation of the models in order to visualize them effectively. So considering these industry trends and challenges, NVIDIA has been working hard on developing technologies that can help AEC design teams improve their building design workflows. Earlier this year, we introduced NVIDIA Omniverse, which is a computer graphics and simulation platform that enables AEC firms to collaborate in real time on a photoreal digital twin to help teams maximize productivity. Omniverse was built by NVIDIA as an internal tool to simulate virtual worlds for our development of autonomous vehicles, robotics, and so on. We recognized the benefits the platform delivered for our teams, so we initially offered if you like, an alpha version to a limited set of customers with whom we work closely to play with it and find out if it would be helpful for them. Several of those customers are leading architecture firms, so we built on the Omniverse platform the AEC experience, a set of tools and extensions focused on concept design, visualization, and design review. So let me dive into some detail about Omniverse. As you may know, NVIDIA has a history of developing SDKs, software development kits, to facilitate use of GPU-accelerated technologies. You see a few of them here at the top. These are aimed at interactive ray tracing or for accurately simulating wind flow and rigid and soft body dynamics, or VR works to push the boundaries of high-fidelity virtual reality. Traditionally, when new technology gets introduced, it could take a year or longer for ISVs, for software vendors, to implement these in their products. Obviously, they have to commit resources and schedule the work, test it, and then release it to their customers. What if we were able to bring out a new technology and that very same day applications could take advantage of it? That's one of the core advantages of the Omniverse platform. Based on Pixar's Universal Scene Description Framework, or USD framework, and NVIDIA RTX, built on a unified architecture which is shared by all applications in real time. So when we enable a new technology, all the products using Omniverse have access to it immediately. You keep hearing me refer to Omniverse as a platform. Now let's look at the various components. Omniverse Nucleus is the file server that hosts and synchronizes the shared USD files. Omniverse Connect is integrated into software applications such as Autodesk Revit, McNeil Rhino, and Trimble SketchUp to connect and collaborate on the same scene file hosted by Nucleus. This live connection enables users to quickly iterate on a project together, while Omniverse View is a standalone app that provides a view of the USD scene augmented with real-time RTX rendering. It offers basic scene and material editing capabilities, as well as industry-specific features like light or sun studies. Then there's a simulation module included for experimentation and customization and to accurately simulate the virtual world. And RTX Render is available for those who need the highest possible fidelity when visualizing fully ray-traced, physically accurate building models in real time. Here's a brief video that showcases how the Omniverse AEC experience works and some of the features and tools. Hopefully that video helped you visualize the potential of how Omniverse could help overcome collaboration challenges for you and your teams. We saw how project teams are unified on a single interactive platform, even when simultaneously working with different software applications, allowing a team to rapidly develop architectural models in real time. And you get seamless updates and changes to further simplify collaboration. We saw the ability to go from design to ray traced view in one click, so you can see beautiful, physically accurate visuals with minimal effort. When you watch interactive ray tracing of the building model taking place in Omniverse in real time, it's hard to believe it's not a filmed video. You don't have to do any data prep or decimation of the model, which means you avoid wasted time and costly delays in translation and errors between software tools. And teams can speed up the design approval process since decision makers can view that high fidelity model on just about any device from anywhere. We're fortunate at NVIDIA to work closely with a lot of great people at leading firms all over the world. And we're gratified that several of them took the time to evaluate Omniverse and offer feedback and recommendations, which really helped us refine the platform over the past several months. Woods Backett, of course, a global architecture and consulting practice, has team members located all over the planet, so remote collaboration is a big deal for them. You can read their impression here. We were also very pleased to get input on Omniverse from Cohn Peterson Fox. Many of you will be familiar with KPF, who are particularly known for their designs of super tall buildings. For KPF, the ability to get physically correct visualization at the highest fidelity with real-time ray tracing is a huge benefit to their design teams. So we've had plenty of feedback and encouragement from customers helping development of Omniverse, as well as support from our partners in the software space serving the AEC industry. We're at the beginning of developing Omniverse, and the platform will continue to evolve as we add features and functionality in the future. I'm pleased to tell you that we have just announced that the NVIDIA Omniverse Open Beta will be available in the fall. So I invite all of you to try out this early version and evaluate how it helps your collaboration workflows. Just type NVIDIA Omniverse into your online search engine to find out how to access it. Well, that wraps up my presentation on overcoming collaboration challenges in architectural design. Be sure to join us for the live Q&A at the end of today's sessions. Thanks for watching.